Good to go. For those of you listening at home, hi Michael. We are just starting notes on the next section. We had just checked off homework 7C, where this is the notes for homework 7D as in Douglas. Just starting a story problem. You want to buy a batch of mixed fruit, in this case it's apples and bananas. And here's what you know so far. Apples are, in this particular problem, 25 cents each. And bananas are 10 cents each. If your batch includes 30 pieces of fruit, and costs, and let me kind of cheat and grab a calculator here because it'll be a lot faster than I'm doing it in my head, and there's probably less chance of it being wrong. Let's see. $4.95. How many of each were bought? You might notice this is a pretty contrived problem. It does have application. I have used this, I can't remember off the top of my head exactly when, but this type of problem, if all you know is you bought, I think it was on a sales receipt once, where I bought a certain amount of something or other and a certain amount of something else. And I didn't, and the receipt was one of the things that faded with time, and I was doing my taxes. I was trying to figure out how much of each did I buy, because I want to know how much they are, because one of them was taxable and one of them was not, which was really annoying. But anyway, does this kind of make sense? Go ahead and finish writing this down. So you want to buy a batch of mixed fruit. Apples are 25 cents each, bananas are 10 cents each, 30 total pieces of fruit. Yeah, we're not counting the basket. And the total cost is $4.95. How many of each were bought? Now, one way people do this is they just start guessing and checking. They say, well, how about 30 apples and no bananas? And they check it. All right, how about 29 apples and 1 banana? All right, you can do that, but you have to, there'd be 31 possible guesses on this thing. Once you get down to like 0 apples and 30 bananas, that's tedious. And if your time is limited on the test, that can sometimes be the kiss of death for the points in the problem, or on the problems that you didn't get to because you spent so much time on this. Here is here's a way to do story problems like this. If you have, well, let me just ask the question. What are the unknowns? What are we looking for? What do we not know yet?
How many apples and bananas?
Yeah. Do we know the cost of each?
Yes.
We do. So we're not going to worry about those. I don't know how many apples and I don't know how many bananas. If there's something you don't know, what do you call it in algebra?
Variable.
A variable. Like what?
X.
X or Y. And in this case, you can do A and B. I would say A is equal to the number of apples. I would ask you to be specifics. Wow, specific. Can't talk today. And then B would be the number of bananas. This is a technique called defining our variables. To define something is to give it a definition. In other words, to say, here's what it is, here's what it isn't. So, and you have to be specific. If you just say A equals apples, I may actually take off points on the test if you do that. Like if you don't have the number thing. A equals apples could mean the price of an apple, could mean the weight of an apple, Could mean the temperature of an apple, the calorie content of an apple, could be anything. The number of apples is something specific. Okay? Now, according to this, whenever you read a story problem, there's usually a whole bunch of English words and some numbers. We are much more interested in the numbers than in the words. Some of the words are important, obviously the word apple and the word banana are pretty important. But the numbers are really important. Here's the beefy part of the problem. The fruity part of the problem, whatever. How many fruit do we have total? 30. How would you get the total, like mathematically? Like if you just pour a bunch of fruit in here, like what exactly are we doing to get the total? Like how many apples do we have?
A.
Yeah, we don't know, so we're using A. How many bananas do we have? B. What's the total?
30.
What's that?
30.
30. And how would you use a formula to get the total?
Wait.
Close.
8 times B was 30.
Not times, plus. Here's the formula. This can be translated into A plus B equals 30. Does that make sense? So the apples, number of apples plus the number of bananas should add up to 30.
But it also needs to add up, so then you'd also do
Something has to add up to what?
A plus B equals 4.95.
Let's find out. Definitely something adds up to 495. 4.95.
No, it wouldn't be.
So here's your catch. This is the amount equation, and this is the cost equation. So let's think about the cost for a second. Suppose for the sake of argument that I have 4 apples. How much money is that? How do you get that sequence?
0.25 times 4.
Right. It was the cost times 4. What if you have 10 apples? Anyway. $2.50? How do you get that? Yeah, 0.25 times 10. So 0.25 times however many. How many apples do we have? A. It's an unknown. If I have a pile of unknown apples, just like in my duffel bag there, and as I'm not telling you how many, how much money how much money are there? How does that work? How much does it cost? I'll have to think about that. How much money is it worth? Yeah, how much money is it worth? How much money are they worth? Man, that's frustrating. Sorry for the English teachers. I apologize. I'll think about it in a minute. That's totally annoying. Anyway, so how much does it cost if I have an unknown pile of apples? How much money is it worth? Hey, got it.
9.5.
That's the apples and bananas together. How about just a pile of apples, period? You can't give me an answer. You can only give me a formula.
A plus B equals 4.95.
Well, A, let's start from the beginning. A is the number of apples. Like if I have 10 apples, does it cost 10? What does it cost?
2.5. 2.50.
Yeah, 0.25 times 10. What if I have 100 apples? How would you calculate that? 0.25 times 100. What if I have a number of apples? Give me the formula.
0.25 times A.
Ding, 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 ding. So 0.25 times A. Jackpot. Can you do that trick with bananas? How much does a pile of unknown bananas cost?
0.10B.
Say again, I'm sorry? 0.10B. Right. 0.10B. And if you look, we have 2 equations. This is a lot like the equations we were doing yesterday. I want you to solve. You can use substitution. You can use elimination. You can try graphing if you want. I wouldn't recommend it. Elimination sounds good. Now, these, what number is in front here? 1. Does that make sense? I want to get something to cancel. First of all, those decimals are kind of aggravating. You can use them. There's no law against it. But is there a way to get rid of them?
Yeah.
Like how? Yeah, go.
Moving everything 2 spaces
Moving everything 2 spaces, which way?
to the right.
To the right. What mathematical thing are we doing when we do that? By what? 10 would move it over one space.
3, so 20.
Right idea.
Sorry,
What's that?
100.
100. Very good. I'm multiplying this bottom thing by 100 just to get rid of the decimals. This is an optional step, but it's kind of helpful. What would it be? Saker, help me out. Multiply each of these by 100 and tell me what you get.
25A
Yep.
plus 1,000.
Oh, this is over two spaces.
Oh, okay. I thought it was just 10B
Yep,
equals 400.
exactly. 495. And I'm going to leave the top alone. 1A plus 1B equals 30. Yeesh.
I'm a sorting equation.
It happens. So now we actually have to try and eliminate something. Any suggestions?
Multiply the
You want
top,
the A's or the B's?
the B's.
Why do you say that? The B's are probably easier.
Could, yeah, be easier to get into.
Say again, sorry?
It'd be easier to get them to match up, I guess. I don't know.
Why?
They're smaller numbers.
Yeah, it's smaller. Yeah. But you can work on either one. It doesn't really much matter. But yeah, I kind of like the B's also. So, suggestions?
Multiply the top by -10,
By -10 sounds good. Why negative?
so that they can cancel.
Right. They're not, one of them's not negative yet, and this is just, keep it the same way. Let me put this down here. Jenny, can you give me the top multiplied by -10?
Negative 10A plus negative 10B equals negative 300.
Good. And then the one on the bottom is 25A plus 10B equals 495. I gotta be really careful on this because I wrecked my knee yesterday during fourth period. I don't know what I did. I just knelt down because I do this all the time and I heard the crack. What happened? What sort of stupid thing did I do to myself? So, I'm being good. What you do now?
B's cancel,
Yes, if you add these equations, the B's cancel, what's left?
20 or 15A.
Good, 15A equals
Equals, 195.
195, good. So, question, no math people, does 15 go into 195?
Yeah.
Let's find out. Does 15 go into 19?
What?
How many times does 15 go into 19?
Once.
Once, and that's like 4 left over. How many times does 15 go into 45?
Thrice.
Ah, I like that, thrice. It's very Shakespearean it is. So, A equals 13. Are we done?
No.
No. What do you do now?
17 again.
Yes, Mr. Turbo. So how do you get that?
There has to be 30, so.
So technically what, you can do it in your head, but what we did was we plugged this in. 13 plus B equals 30, and subtract the 13. So what do you get?
17.
Yeah, B equals 17. There's just one catch. Whenever you have story problems, if the problem is in words,
But the answer.
yes, the answer must be in words.
So, 13 apples. 17 bananas.
In words. Exclamation point. So yeah, the final answer on this would be 13 apples. Sorry about the weird looking L. And then 17 bananas. So people might say, if I could guess and check this quickly, can I? At your own risk. I don't encourage that, partially because some of these story problems, I mean, pieces of fruit are, it's kind of hard to have, you can have half a banana or something like that. You usually don't buy half a banana, that's weird. But if you're going into, say, a chemistry shop, and you want two different chemicals, chemical A and chemical B, you might not necessarily get a whole number. You might get 2.5 ounces of chemical A and 1.3 ounces of chemical B, and good luck guessing those. So, but if you set it up like this, you should be able to solve it even if the answers are fractions or decimals. It should work no matter what. Does that make sense? Alrighty. The majority of the homework is not story problems, believe it or not. let me just write the homework down. And for those of you listening at home, hi Michael, I'll write it on the front board in a moment. I'm just putting it over here. Keep it for posterity. Do keep in mind there's no school on Monday and Tuesday. I'm pretty sure nobody's forgotten that. Starting on pages 421, I think.
The 7D.
It is, yeah. Page 421 and following. I would like you to do. Let me see. I'm going to skip 10 through 18. That's one of those choose your own method. I would like to do. Wow, there's a lot of them here. In a second. I'm going to kind of modify this. I'm going to go from 15 through 45. But I want you to do just multiples of 5. So that should cut it down quite a bit. I would also like you to do number 46. And 49 and 50. Because those go together. And that will do it. So, Michael, for your sake, this is on pages 421 and following. This is number 7D. 421 and following, numbers 15 through 45. This means multiples of 5. I'll explain it in a second. And then 46, 49, and 50. I put a dash there because these two are related to each other. Did I tell you this before? Whenever I do this notation with the times 5, do you remember that? The poor soul, two schools back, they did 15, 16, 17, 18, 19, 20, 21 through 45, and then they did it again, and then they did it again, and then they thought they had to do all these problems 5 times. That's not what I mean. No, that was so awkward. So everybody good to go? All right, call me if you get stuck. Otherwise, you get about 20 minutes. Go ahead and pound away at that. And we're good to go. And I think we can cancel the video. So,
Bye, Michael.
Michael, that was going well. This is my hand waving goodbye. Bye-bye.